Okay, so for problem number 2, determine the speed at which the basketball at A must be thrown at the angle of 30 degrees so that it makes it to the basket at point B. So for this problem, no, again, sa nakikita natin, if this is your reference point, kung saan yung, that is the reference kung saan yun ilalunch yung bola. Okay, so sa nakikita nyo yung bola from the reference line, that is nasa itaas, so that is positive. So let's say this is YB. So that is YB is equivalent to positive YB. Okay? YB in this case will be equal to 3 minus 1.5. Tama ba? So yung YB natin would be 3 minus 1.5 or that is basically equal to 1.5 meters. So yan yung gagamitin natin na YB. So 'di ba, recall that kanina meron tayong formula na since we are not given with time, no? We are not given with time. So nakuha natin or na-derive natin yung formula na y is equivalent to x tangent theta minus 1 half gx square over v initial square cosine square theta. Okay? So, just ano lang, no? Review lang this one. Nakuha natin yan kanina. Dinerive ko yan. Wherein, kapag yung y is above the reference point, positive yan. Okay? Which is positive. Pagbaba naman, that is negative. So, ito yung gagamitin natin na formula to solve for the value of your velocity initial. Wherein, in that case, VA. Okay? Ito, VA ang ating gamitin for that. Okay? Sige. So, dito na lang, no? YB is equivalent to x tangent theta minus 1 half g, and then we have here x squared over VA squared, that is cosine squared theta. Okay, so let us identify muna yung mga components. So again, we now have the YV which is equivalent ng 1.5 meter. Okay na yan. And then yung tangent theta would be 30, and then we have here our x. Okay, so diretso na. This is 1.5 meter equal to 10, and that is tangent 30 minus 1 half, then 9, SI ba tayo? Yes, SI, 9.81. Then we have x, okay, x is 10 square. Then velocity, nahanap natin. Then cosine, okay, cosine, so di ba pag ganyan, cosine 30, then square mo yan. Tama ba? Okay, ganito yan ha. Okay, therefore, kung i-shift solve natin to, okay, shift solve na natin, no? Or you can just you can just do algebra for this, although madali lang man din yung algebra. Okay, 1.5, so shift solve na natin, is equal to 1.5 is equal to 10 tangent 30 minus 0.5 9.81, okay, over 10 square over x square, yan yung hinahanap natin. Then we have here cosine 30 and then square. Okay? So, shift solve, let's say, nasa mga, lagay natin, set natin is 10. Okay? Para madali. Okay? So, as you can see, 12.37. Okay? Therefore, you need to shoot the ball at a speed of 12.37 meters so that punta siya sa basket which is 3 meter above the ground. Okay? So that is basically your answer for this problem. Okay, let's try another more problem. So problem number 3, track of this racing event was designed so that the riders jump off the slope at 30 degree. Find the height from a height of 1 meter. Now, during a race, it was observed that the rider shown in the figure remained in mid-air for 1.5 seconds. Ano sabi dito? Ano ibig sabihin ng mid-air? So that is basically the total time it takes for this rider from this point A papuntang point B. Yan yun ha. That is the total time na na-consume niya following this path or projectile. Now, determine the speed at which he was traveling. So, may tatlo ang hahanapin dito. So, una ito, determine the speed at which he was traveling of the ramp, or that is basically your initial velocity or VA, kasi dito tayo sa point A. The horizontal distance, that is letter B, which is equal to R. Ito yon. And the maximum height attains. Maximum height, ito yon, H. Okay, that is maximum height. Okay, neglect the size of the bike and rider. So, tatlo ang hanapin natin for this problem. Okay, so una, you need to you need to recognize na sa nakikita natin, yung projectile natin or yung final destination ng projectile natin is at or below the launching point or launching axis, okay? Or reference line natin. So, that means this one right here is negative YB. Sabihin natin YB. That is equivalent to 1, no? Or that is negative 1. Tama ba? Okay. Tama na. So, una, makukuha natin first yung velocity. We need to consider first the velocity. So, di ba, yung formula natin, y is equal to initial velocity, okay? So, we cannot use the x tangent theta because unknown din yung r natin or yung x. So, instead of using that one, gamitin natin yung original, which is v a y t minus 1 half, then we have g t square. As you can see, yung yb, b natin is nasa baba. So, this is negative yb. And then we have velocity initial at y, t. Yung t given na yan, which is 1.5 seconds. Ito yan. Okay? Then g is, this is SI 921. So, we can solve first for the value of VA. Okay? So, VA would be equal to negative 1, yung YB. Yung VA y, that is equivalent to initial velocity sine theta. Okay, tama ba? So, VA, ang sine, ang theta would be 30. Okay, sine 30 minus 1 half, then 9.81. Ay, sorry, meron pa palang time, which is 1.5 seconds. Okay, minus 1 half, then we have here 9.81, then we have 1.5 square. Kuha ba? 1.5 square. Okay, therefore, VA is equivalent to, shift solve na natin, negative 1, sorry, negative 1 alpha VAX, and that is sine 30 times 1.5, okay, minus 0.5, 9.81, then we have here 1.5 square. Okay, shift solve. So for the value of VA, that is equivalent to 13.38. Okay, 13.38 meters per second. And that is the value of your speed. Okay. Now, let's proceed to letter B. The horizontal distance. Since we have now the value of VA, for horizontal distance R, again, that is under constant velocity lang. So that is VA along X times T. In that case, we have here VA cosine theta times T. That is your R. R therefore is equivalent to, ang nakuha natin, 13.38 cosine ng 30 times 1.5. Okay, so therefore your R would be equal to, okay, 13.38 cosine 30 times 1.5. And that is equal to 17.38. Okay, sorry, 17.38, and that is meter na, ha? Since this is meter per second times seconds, so makakansel yung seconds, meter na lang. Now, for letter C naman, ano yung tanong sa letter C? Maximum height attained. So, ito yun, H. Pero, hindi pwede natin diretso H yan, no? H is equals to something like that. We need to understand na kailangan natin gamitin is yung, okay, we need to set a reference line. Ito yun. Kung saan yung launching point natin, yan yung magiging reference line natin, no? Ito yung, let's call this YC. Okay, YC yan. Ang YC by definition, that is H minus 1. Tama ba? H minus 1. Okay, yan yung YC. Wherein ang YC is the maximum height at which yung initial velocity dito, mapunta dito. Okay, di ba? At this maximum or peak point, your velocity here would be equal to 0. Momentarily mag-stop yan. So, in other words, we can use the equation ng free falling, okay, or rectilinear motion pero vertical component, velocity final squared equal to velocity initial squared plus, okay, or no, minus kasi going downward yung gravity, you know, so that is 2g, and then we have here your yc. Okay, yun ito yc yan kasi dapat measured from the reference point or launching point. Okay? Wherein yung velocity final at that highest point is equal to 0 yan. Okay? And then yung V1 initial velocity is actually your initial velocity y component, or that is v a y. In other words, that is v a sine theta. Now, yan yung gagamitin natin for this one right here. Okay, ito ba? So that is equivalent to 13.38. Then we have here sine of 30 squared minus 2. And then we have here 9.81. Again, yung yc natin would be equal to h minus 1. Okay? So shift solve. Kuha natin yan. 0 squared is equal to, okay, we have here 13.38 sine of 30. And then square minus 2 times 9.81 times x minus 1. Okay, shift solve 1, let's say, we get 3.28. Okay, so h would be equal to 3.28, and that is in meters. So basically, this is your answer for that problem. Okay, so pasensya na po if medyo noisy yung surrounding ko kasi nasa probinsya, and then mga tao dito is mga medyo you need to yell, no, para marinig ang isa't isa. Okay, anyway. Okay, that is for problem number 3, no. Now, for problem number 4. This is the last example, for projectile motion. Okay? So, a sack slides off the ramp. Yung sako, no, shown in the figure with a horizontal velocity of 15. If the height of the ramp is 8 meters from the floor, determine the time needed for the sack to strike the floor and the range R where sacks begin to pile up. So, dalawa yung pinapanap dito. Una is the time, and the next would be the distance R. Okay. Now, for that time, as you can see, yung velocity natin is only or purely horizontal. Horizontal lang yan. Wala siyang angle or whatsoever. Okay? So, for this type of problem, okay, initial velocity, that is purely x. Although, at this point, meron na siyang velocity at y, velocity at x. Pero, initially, horizontal siya. Okay? So, in this particular problem, to solve for the value of t, we will be using the concept ng free falling pa rin, in which yung velocity natin, vertical, initial will be 0. Okay? So, for letter A, okay, so gagamitin natin na formula would be the height, no, or y is equal to what? Your initial velocity along y, okay, times time minus 1/2. Then we have here g t square, wherein yung y is nasa baba, so negative yan. Okay? Since our velocity, again, at initial point is 0, so ito, magiging 0 yan. Okay? So, negative of 8 equal to negative of 1/2. Okay? Negative of 1/2. And then, nasa isa tayo, 9.81, then t square. So, therefore, t would be equal to what? So, negative, makakancel lang yan, no? So, therefore, we have here 8, multiply na natin. 8 times 2, and then divide by 9.81, and then you square it, square, and that is equal to 1.277. So, 1.277 seconds. Basically, this is your answer for the first unknown. Okay? Now, for the second unknown, the value of R. Okay, since nandito, kapag horizontal, we are dealing with constant velocity, no? So, madali lang yan. Yung R would be equal to velocity along x and then time. Wherein yung velocity along x is already given. Initial velocity. That is 15, purely, times 1.277. And that is basically equal to what? Okay, this is multiplied by 15. And that is 19.157. Okay, 19.157. And that is in meters. Okay? So, I hope na-master nyo, no, yung projectile motion under curvilinear motion. So, we'll have our exam on Monday still, and you need to study this one. Okay? I wish you good luck and keep safe, everyone. I'll see you around. Thank you.